let's discuss the property of equality when it comes to logarithms. So basically, if you have two logs with the same base, let's say it's base b, then we know that x is going to be equal to y. And if that was a little confusing for you, let's look at the numbers down below. Be less vague. So here we see that we have base 2, so we can say that the x is equal to the 7. And that's it, folks. Basically, if you have the same base and you have two expressions attached to those bases, you set them equal. So for example, here, notice that we have the same base, and that is base 8. So we can drop that, the log base 8, and we can say that 4 minus 3r is equal to r. So to solve for r, we would just add 3r to both sides. That disappears, and I get 4 equals 4r. Of course, we're going to divide by 4, and we get r equals 1. And we're done. So it's as simple as saying, hey, these are the same log bases, and then I'm just going to let this equal to that. Now on this next problem here, you can see that we have subtraction, and so your mind should automatically go to division. From the last video, we learned that we can take subtraction and make it division if we have the same base, which we do. So I'm going to rewrite the left side of the equation as log base 7, and then the x minus 2 goes on top, and then divide by 6. And now I'm just going to rewrite the right side. Okay, so now I both have log base 7, so I can drop the log base 7s and have x minus 2 over 6 is equal to 4. Okay, now I'm going to multiply by 6 on both sides. That cancels, and I'm left with x minus 2 equals, well, 6 times 4 is 24. Add 2 to both sides. That disappears, and I get x equals 26. And I'm done. Okay, now this next one you should say to yourself, addition is the same thing as multiplication so in terms of logs if we have the same base. So I'm going to rewrite this as log base 7 of 4 times 5x, which is a 20x, and that's going to be equal to my right side. Again, we can drop the log base 7s by the property of equality, and I get 20x equals 5. I'm going to divide by 20, and I get x equals 5 over 20, which is a 1/4. I just divided all these by 5. And so you should be saying, hey, this isn't too bad at all. All right, this next one here is our last one, and it's our hardest one, and we should recognize that our addition should become multiplication. And these are a little confusing, but this is log base e and log base e. So we do have the same exact base. So I can rewrite this as natural log of x plus 5 times x plus 2, because remember, addition becomes multiplication, and that's going to be equal to ln 4. Well, now that they both have ln 4s on both sides, we can drop the natural logs, and this is going to be an x plus 5 times an x plus 2 is equal to 4. So let's go ahead and FOIL this out, F-O-I-L. That's going to give me an x squared plus a 5x plus a 2x plus a 10. And now we can go ahead and we can combine our x's on the left side. And of course, whenever I'm solving an equation with the quadratic, I need it to be equal to 0. We learned that in Algebra 2. So we're going to subtract 4 from both sides. I'm going to get an equals 0 and an x squared plus 7x plus 6. So let me just rewrite that up here. And at this point, we can solve this problem either by quadratic formula, we could graph it and find the zeros, or I actually think the easiest way here is going to be to factor. So we're trying to add to 7 and we're trying to multiply to 6. So that's going to be a 6 and a 1. So it's going to be an x plus 6 times an x plus 1. So certainly 6 times 1 gives us our 6, and 6 plus 1 gives us our 7. So this is going to be equal to 0. And then solving this, I just get an x equals minus 6. And I get an x equals minus 1. So we always need to check these